Greetings! Welcome to this comprehensive guide on the Linux file system hierarchy. By the end of this tutorial, you will have a solid understanding of how files and directories are organized within a Linux system. We will explore the standardized structure that defines where various types of files are stored, how system resources are accessed, and how configuration files are managed. So let's dive in and unlock the secrets of the Linux file system. Let's begin by understanding what exactly the file system hierarchy is. The Linux file system hierarchy is a standardized directory structure. It defines where files and directories are organized on a Linux system. This organization is crucial for a number of reasons. It determines how system resources are accessed, ensuring that the operating system can find and use necessary components. It also dictates how configuration files are stored, enabling consistent system behavior. Finally, it specifies where applications and their data reside, ensuring that software can be properly installed and executed. This standardized structure allows users and applications to locate files in a predictable manner. Let's explore some of the key root directories that form the foundation of the Linux file system. First, the /bin directory. It contains essential command binaries that need to be available in single-user mode, such as ls, cp, and mv. Next, the /boot directory contains the files needed for system boot, including the kernel and bootloader, ensuring that the operating system can start correctly. The /dev directory, it contains device files that represent hardware devices and virtual devices, such as hard drives, keyboards, and network interfaces. The /etc directory, it contains system-wide configuration files and shell scripts used during boot. The /home directory contains user home directories with personal files and configurations, such as documents, pictures, and settings. Finally, the /lib directory contains essential shared libraries and kernel modules needed for boot. These libraries are crucial for running many programs on the system. Let's continue our exploration of key root directories in the Linux file system. First, the /media directory. This serves as the mount point for removable media, such as USB drives and optical disks, allowing easy access to external storage devices. Next, the /mnt directory is a temporary mount point for manually mounted file systems, typically used for accessing network shares or other file systems temporarily. The /op directory is used for optional application software packages and add-on programs, providing a location for software that is not part of the base system. The /proc directory, which is a virtual file system providing process and kernel information, allowing users to view and interact with the operating system's processes. The /root directory serves as the home directory for the root user, which is the system administrator. Finally, the /var directory stores variable data files, such as logs, spool files, and temporary email files, which change during normal system operation. Now, let's learn how to navigate the Linux file system using essential command line tools. First, the command pwd, which stands for Print Working Directory. It displays the current directory you are in. Next, the command ls, which stands for List Directory Contents. ls command lists the files and directories in the current directory. The ls-l command provides a detailed listing with permissions, size, and modification date. The ls-l command includes hidden files and directories in the listing. Finally, the command cd, which stands for Change Directory. The cd/path/to/directory command changes the current directory to the specified path. The cd command changes to the current user's home directory. The cd command moves one level up in the directory hierarchy. The /etc directory is a central location for system-wide configuration files. These files control how the system and applications behave. Some key files include password, which stores user account information. Shadow stores encrypted passwords, enhancing system security. Hosts maps IP addresses to host names for local network resolution. Stab contains file system mount configurations. Resolve.onf configures the domain name system resolution. In addition, the directory contains subdirectories such as SSH for secure shell configurations and systemd for system service management. System administrators regularly modify files and etc. to configure system behavior, network settings, security policies, and service configurations. The /home directory is a crucial part of the Linux file system. Its purpose is to contain a subdirectory for each regular user on the system, where they can store their personal files and configurations. Each user gets their own directory, typically named /home/username. This directory includes user-specific configuration files often referred to as .files, personal documents, downloads, and data, as well as user-installed applications and scripts. By default, each user's home directory is readable only by that user, providing privacy and security for personal files. The /var directory is designated for variable data files on a Linux system. These are files whose content is expected to change during normal operation. Key subdirectories include /var/log, which contains system and application log files, /var/spool, which is used for data awaiting processing, such as print queues and mail, /var/cache stores application cache data for faster access, /var/tmp is for temporary files preserved between reboots, /var/lib is for state information for applications. System administrators often monitor files in the /var directory to track system activity, troubleshoot issues, and manage services. Virtual file systems like /proc and /sys provide dynamic insights into the kernel and system processes. The /proc file system is a virtual file system that doesn't exist on the disk. It provides information about running processes, with each process having a directory named by its process identification or PID. It also contains system information such as CPU and memory, and allows runtime configuration of kernel parameters. The /sys file system exposes kernel device and driver information, is organized by device subsystems, and is used for hardware management and configuration. It is also more structured than /proc. In summary, the Linux file system hierarchy, or FHS, provides a consistent structure across Linux distributions, making system administration more predictable. Proper understanding of file permissions and directory structure helps maintain system security and data integrity. Knowing where configuration files are stored allows for effective system customization and management. The hierarchical structure separates system files from user data, making backups and system maintenance easier. Understanding /var/log and /proc helps with system monitoring, troubleshooting, and performance analysis. Follow file system standards, use appropriate directories for different types of data, and maintain proper permissions to adhere to best practices. For further resources, consider the File System Hierarchy Standard, the man here command, and the Linux Documentation Project. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.